Nye the Science Guy. Bill Nye the Science Guy.
Feel your throat when you talk. You feel a vibration. That's because all sound includes a vibration. A sound source vibrates the air particles that surround it, increasing and decreasing the velocity of those particles away from that sound source. These changes in the velocity of these particles create us to hear sound. Sound waves are longitudinal waves, which means that the air particles move in the same direction of the wave, like dominoes. The sound source pushes air particles together and stretches them out to create sound waves. The closer the particles are, and the more often they are pushed together, the higher the frequency and amplitude. This is the Doppler effect.
Instruments create resonance, which resonance is a small force on regular intervals to increase amplitude. An example is this cup. I'll explain to you why we see certain colors of certain things. Matt here is wearing a white shirt and all colors are reflected. Alyssa here is wearing a black shirt and all the colors are absorbed. Grayson here is wearing a yellow shirt. All colors are absorbed except for the color yellow is reflected to our eyes.
Light shining from this candle is unpolarized light. Unpolarized light is light that travels on all sorts of planes in all sorts of directions. But that light can be transferred into polarized light. These are polarized sunglasses. They have a polarized filter. Polarized light is light that travels in one plane or in one direction. While it travels on one plane in one direction, the other light is reflected back, which makes the light seem darker. Luminous flux is used to measure the useful power emitted by a light source. For instance, light bulbs, your flashlight, or kitchen lights are measured by the luminous flux, or the power emitted. Illuminance is the amount of light striking a surface. So here, this flashlight strikes the paper, causing everything to reflect back.
Frequency is how frequently a cycle occurs. This is an example of high frequency. And as the sound gets deeper, the harmonica has a lower frequency. This represents the amplitude. When the sound is not loud, the amplitude, which is the maximum displacement of energy, is small. Now, as the sound gets louder, the amplitude will now increase. Light is a transverse wave, which means particles move perpendicular to the wave. The color red displays a low frequency, and since all colors have a different frequency, blue, for example, has a high frequency. And that the amplitude of light is determined by how bright the light is. This light has a high amplitude because it is bright. Now, the dimmed light has a low amplitude because the light is not as bright.
Sound travels at different speeds through different objects. Fastest through a solid, second fastest through a liquid, and slowest through the air. I'm going to show you this right now. I hear it travel through the ground faster than I hear it travel through the air. Awesome!
Light travels differently through different surfaces. We have transparent, translucent, and opaque. This shower is transparent. All light passes through it. This next shower is translucent. Some light passes through. This door is opaque. No light passes through.
We're going to mix primary colors with light. When I mix red with blue, it makes purple. When I mix red with green, it's supposed to make yellow. And when I mix blue and green, it makes cyan. When all the colors are combined, it's supposed to create white light. Welcome to craft time. We're going to see what happens when we mix primary pigments. First, we're going to mix blue and red. That makes magenta. Next, we're going to mix red and green. That makes yellow. And last, we're going to mix blue and green. And that makes cyan. Thank you.
Bill Nye the Science Guy. Bill Nye